Hello again, everybody. We are moving on to cubic functions here. Now that we got the intro to polynomial notes done now, we're going to actually start graphing polynomials starting with degree 3, and then later we'll do 4 and then 5. So let's start with just the most basic cubic function you can get, which is your parent x to the third. So let's just get a graph of each here so you know what you're always comparing your functions to that you're dealing with. Let's do x cubed and negative x cubed. So if I plot this here, let's just plug some x values in. 0 cubed is 0, 1 cubed is 1, 2 cubed is 8, and 3 cubed would be above where I am. Negative 1 cubed is negative 1. Negative 2 cubed is 1, 2, 3, 4, 5, 6, 7, 8. Negative 8. And you can just do a quick sketch of this in your notes. I know you probably don't have a graphing grid. So there's x cubed. Wow, that is not smooth right there. Hold on. That's a little better. All right, now let's try some negatives. If I do 0, it'd be 0. Now obviously putting a negative in front is going to reflect this. So if I have negative of 1 cubed is 1, and then negative is negative 1. The opposite of 2 cubed will be negative 8. The opposite of negative 1 cubed is the opposite of negative 1, which is 1, so negative 1, 1, and negative 2 will be 8, and, oh my god, hold on. Okay, so here's my graph of negative x cubed. I'm just connecting my points. One thing to notice is now this is just the end behavior chart we were talking about before. Positive leading coefficient, odd, the ends will look like this. And for the regular old x cubed, as your x values increase, your y values increase. As your x values decrease, your y values decrease. Here at negative leading coefficient odd degree, your ends will do the opposites in this way. So as x is increasing to the right, your y values get smaller and smaller. And as your x values get smaller and smaller, your y values get larger and larger. It's the exact opposite. So let's talk about how we're actually going to graph a cubic that's not just the plain old parent. So let's take a look at a quadratic here just to remind ourselves what we did, because it's a really similar idea for now with a cubic. So if I had a quadratic like this, we would factor it first of all to get into intercept form, and we will just plot our x and y intercepts. Sometimes I had to get additional points, which we will start doing with polynomials soon. So negative 5 and negative 2, multiply to 10 and add to negative 7. And we set this to 0. So we get the x-intercepts 2 and 5. So just like you're going to do with a cubic very soon, we will plot our x-intercepts. We will plot our y-intercept, 10. And then because we had a positive a value, our graph faced up. So you guys already have been thinking about end behavior when you did quadratics. You just didn't have the entire end behavior chart because you didn't need it. Now that we're going higher up, this is just a rough sketch. Now that we're going higher up in a degree, you're going to need to refer to this end behavior chart, which we did here. So let's do our first cubic here. And our first cubic, again, it's going to be a very similar idea to this. When we graph cubics, we're going to factor first. We're going to set the factors to 0 to solve and get our solutions like that. We're going to plot the intercepts, and then we're going to use end behavior to connect the points. Connecting a quadratic is super easy. When we start connecting higher and higher degree things, you just have to be a little bit more careful. So pause the video if you need to get caught up, and then we'll do 2 examples together, and then we'll practice in class. All right, example 1. So this is why you had to know how to factor, because from now on, it's just going to be pretty much all factoring and dividing. So if I see 4 terms here, you automatically should be thinking grouping. Let's see if it works, because it won't always work. Let's take a negative 9 out, and then be x plus 7. Yep, it works, so I'm going to set it to 0, x squared minus 9, and the common factor just gets written once. And I can actually factor this even more. X plus 3. Our goal is always going to be to break it down into a bunch of x's multiplied together, not x squares, just x to the first. So I have negative 3, 3, and negative 7. Negative 3. So sketch yourself a little axis here. 2, 3, 4, 5, 6, 7. All right, now let's pause for a minute and think about end behavior here. I have a positive leading coefficient, and I have an odd degree. That means my ends will do different things because my degree is odd. And what my ends are going to be doing is towards the left, it'll go down. Towards the right, it'll go up. So on the right side of my graph, it'll be pointing up. On the left side, it'll be pointing down. So now let's just connect our points. And let's not forget about our y-intercept of negative 63, which I'm arbitrarily going to say is down here, which is very out of scale, but I don't feel like doing 63 tick marks. So let's get a color here. All right, I'm going to have to start from the bottom because end behavior says on the left it's down. So I'm going to move up, and the first thing I'm going to hit is this x-intercept. So you have to go through it. And then I have another x-intercept right here. Well, in order to go through it, you have to turn around smoothly, no sharp corners. We like curves here. And you have to go through it. And then the next point that I'm going to hit is my y-intercept, so I'm going to keep going down. Now, I don't really know how far down I go. We're going to practice soon methods of more accurate graphs, but for now, I'm just going to go down for a certain amount of time. And then to get to my last x-intercept, eventually I'm going to have to come back up. I'm going to go through it, and then my end behavior matches. It's good. I'm just going to keep going up. And there you go. Let's try another one. So the only thing that's really different is just figuring out how you're going to connect everything. Okay, this one here does not have 4 terms, so I really shouldn't try grouping. I'm going to try factoring out a GCF. Always try a GCF first. So I notice, well, I can take a negative out and I can take an x out. So let's do negative x. That leaves me with x squared plus 5x plus 6. And we're going to go to 0. And don't lose this negative x. It's one of your factors. So 2 and 3 multiply to 6 and add to 5. So if you set everything to 0, well, you'd get 0, negative 2, and negative 5. So let's plot, where am I? 0, negative 2. Give yourself a grid here to plot on. My y-intercept, oh my gosh, there's nothing there. Well, your y-intercept is 0, which you've already plotted as an x-intercept. The y and x-intercept are the same here. And let's think about end behavior. I have a negative leading coefficient and an odd degree. Because the degree is odd, my ends are doing opposite things. And because the leading coefficient is negative, on the left it goes up and on the right it goes down. So here are my little arrow indicators to help me connect. So I'm going to start from the top, go through the x-intercepts, and I should end at the bottom going down forever. So let's start up here. I'm going to have to go through my x-intercept first. Eventually I have to turn around. Eventually I have to turn around again to go through this one. And there you go. And just keep in mind when you connect these, someone else, like you guys might not draw this the exact same because we don't know how low it goes. Wow. So some of you might say, well, what if it goes all the way down there and all the way up there? And the thing is, we don't really know how far up and down it goes because we haven't picked extra points. And someone else could say, well, what if it's really shallow and it just does that? For now, all of those are possible. We are going to figure out how to get more accurate the more we do this. But this will be fine. So we're going to practice in class, and I will see you soon.